Is my screen visible?
Yes, it is. You may continue.
Okay, awesome. Mm, Okay, all right. Good afternoon. My name is Vritee Agarwal, and today I'll be presenting our project that I did with my teammate Siddhant. This is basically a disease prediction plus a lifestyle analyzer project that we did. So it predicts the disease or like the likelihood of multiple health or chronic diseases.
Understood.
So basically what exactly our system does is that it predicts the 5 chronic diseases that we chose. We started off with erythema, but we decided to include 4 more, which were cancer, asthma, obesity, and diabetes. And how it exactly works is that the user first selects whichever disease they feel like they have symptoms of or they want to check for, and then they enter their health information. So it could be like clinical data or it could be like personal data, for example, their age, gender. And then for clinical data, it could be like their blood pressure, their cholesterol levels, what kind of like their blood sugar levels after fasting, before fasting, etc. And then we use AI. So initially, well, for the diseases, we used model training, and then we use AI at the end to go over all of this data and give personalized health tips, diet suggestions, lifestyle suggestions, and whether or not they have this disease or not. So basically predicting whether they have the disease or not.
Got it.
So what makes it special is that we're not just using like one AI model, we're using like 5 different specialized models that we trained for each specific disease, which we very purposefully did because we wanted to make the predictions more accurate. And then we use like Streamlit because it has like pre-made interface, like a user interface. So we wouldn't have to do that from scratch. And then we combined Gemini AI so we could get, again, more accurate results.
Okay.
Yeah. So when we were thinking of like what problem statement we should have, me and my teammate put down our ideas in like a single place. And he had one specifically for arrhythmia, like heart condition. And he wanted to like predict if a person had that or not. And one of my ideas were like lifestyle analyzing. So like based on our diets, based on what exercise we're doing on a daily basis, what kind of activities we're doing, how much we're sleeping, what are our stress levels according to us. So we ultimately decided to combine the two because they were in a way interconnected because I've seen in my own family that heart conditions really just arise from what kind of lifestyle one person is leading. So we decided to combine the two. And then we discussed a bit more and we were like, let's add a couple more like chronic diseases to the list. And that's how we like decided on doing asthma, obesity, diabetes, and cancer as well.
Okay.
Yeah. So, and instead of like, so the main thing about our model, our project is that we didn't just want to give yes or no answers. We didn't want to just be like, yes, you have this disease, or no, you don't have this disease. We also kind of wanted to give a deep dive on what they could do to improve their life or how they can prevent this disease from happening, or like what they could do to basically just understand what changes they can make to their life so then this disease wouldn't be as fatal to them. Overall, like it's a combination of machine learning and AI, so it makes it like really analytic as well, but accurate and kind of like human-like in a way as well because of all of the descriptions that Gemini gives with the lifestyle that the user inputs.
Understood.
And this really matters as well because like heart disease is still like the #1 global killer. It's like there are so many people, like I personally know so many people, close people to me, like families and friends that have unfortunately passed away from a different kind of heart disease. And even my teammate, even he was like talking about how he knows people that have also passed away from heart diseases. So that was something like really close to us as well, which is why like our initial idea was just doing a heart disease like arrhythmia to be specific, but it was later on that we decided to do cancer as well because like the survival rates for cancer is also like when they're detected early on, we did a little research, and the more early they're detected, like the significant there's like a significant increase in like survival rates. So that's
Understood.
why we decided to include cancer. For diabetes, it's like so many people have diabetes. My own grandparents on both sides, like my mom and dad sides, both have diabetes. And then even my teammate, he was like, he knows so many people close to him that have diabetes. So we, again, did a little research on that, and like almost more than 500 million people, like from ages of like 20 to like 80, I think almost worldwide have diabetes. So that was the reason we included diabetes. And with asthma and obesity, like again, our main point with that was that the earlier it's detected, the earlier you know that this is something that you have to work on in your life, the better it is, and the lesser complications you have later on in life. So
Understood.
yeah, that was one of our main reasons why we included these 5 specific chronic diseases. Now coming down to like the workflow of things. So a first step was obviously like collecting all the data, because we were using diseases again, so we need like really accurate, good data sets. So we used Kaggle for that, and both me and my teammate, we looked around for what data sets we could use. We sent it to each other, we went over the things, and we decided on specific data sets for each of the diseases, and we used those. So each data set had like real patient data, like symptoms. They were like test results, again based on like blood sugar levels, their what else, like high blood pressure, etc. So we like used all of these data sets from Kaggle, and then we kind of used Pandas, the Pandas library, Python library, to format these data sets. So because like we need good, clean data so we can use it to train our models later on. So the second thing was like model training. So we created like 5 separate Python programs, each for each disease. And we used Scikit, which is like one of the most popular machine learning libraries, I think. So we use Scikit-Learn to build and train these models. And each of these models, we use a random forest classifier, again, purposefully, because it is a very powerful algorithm that like combines multiple decision trees. And it just, again, it makes things very accurate, and it gives accurate predictions. So we trained each of these models, like for all 5 diseases, on 70% of the data, and we tested it on the remaining 30%, so we know how accurate things are. And then we like use those accuracy scores to measure how well they would actually perform. Then we like saved all of these trained models as .joblib files using the joblib Python library again. So this, and again, we did that because it would like allow us to easily load them on later on in our main application.
Got it.
So then, yeah. So the next thing was like our main application, which was predict.py. And here we used Streamlit. So Streamlit, again, a library that we used to turn our Python code or like scripts into web apps, basically. And again, so we wouldn't have to write the user interface from scratch. And that's why we ended up using Streamlit.
Okay.
So what happens basically on the user interface is that you select which disease, and then you put all of your data, your clinical data, your personal data, and then you get like instant predictions from our AI. And then we had, oh, sorry. Sorry. And then we used Google's generative AI, so like Google Gemini AI, and we use this again for accurate data. And initially, we were planning on just doing this to analyze the user's lifestyle choices. So like how many hours they're sleeping, what are their stress levels, what kind of diet they have, how much water they're drinking in a day. But at the end, like we kind of discussed, and we decided to also put all our clinical data through Gemini AI as well. So again, just for more accurate results. So this kind of made our system not just like technical, but also kind of helpful for everyone that would be using it. So again, just a brief overall of how the actual user interface is. Like you choose one of the 5 diseases, and you put all of your health data in it. Then the AI model like analyzes all of the data, including the clinical data, and using the trained models that we had for each disease, we get a prediction on whether you have the disease or not. So it's a yes or no. And then after that, it kind of gives like personalized advice. So if the AI goes over each point, like if you drank 2 liters of water each day, then is that good? Is that not good? If in your meals you had like eggs and bread, so then it's gonna be like, no, you gotta have like vegetables, you gotta have fruits, protein, you gotta have like more immune building food items that you need to consume. So just a really nice deep dive on things. Um, and this brings us to our tech stack. So here, basically, we used Python as our programming language, and then we used 5 main libraries. So Scikit-Learn, Pandas, Joblib, Streamlit, and then the Google Generative AI. We got all of our data sets from Kaggle, and we used VS Code to write down all of our code, and then we used Streamlit Cloud to deploy our app because we used Streamlit, obviously, and GitHub as well.
Understood. Yeah.
Yes. So basically, after all of this, like for the applications and future scope, one of our main applications that like literally both of us thought of and we like sent it to each other was that it would be really useful in rural places. So if you don't have hospitals, if these places don't have hospitals like nearby, if they don't have hospitals at all, or even if they have hospitals, they're not good enough. So this web app could be really, really helpful in those cases. Obviously, it's not the most accurate thing in the world, but like it's kind of situation of something better than nothing. And we worked really hard on like getting it to be accurate and be good enough as well. So
Okay.
it being helpful in rural places is one of our main things, and then also it could be used in clinics for like a pre-screening, a AI-based pre-screening. And obviously you wouldn't depend on it, but it could just give a brief note to the doctors or the nurses or whoever's going to check with the patient that, oh, these are the things that the patient has. And the patient themselves can kind of like just be in a state of mind where they're like, okay, nothing's really like wrong with me, or like I'm okay, like this is my data that I gave, and AI was like, okay, this is good enough, or this is decent, or this is how you can make better choices. And in terms of future scope, definitely one of the things that we want to do is like adding more types of chronic diseases and like using like larger data sets to again train our models on those. But yeah, adding more diseases is one of our main things. And then we also wanted to kind of expand on like mental health, on like sleep quality and on like stress levels, etc. Because like that is something we kind of did already by asking like how many hours do you sleep, or like how much water do you drink, what do you think your own stress levels are. But we want to do like a more deeper and more accurate prediction based on mental health as well, like anxiety levels, whether you could have depression or not, because all of these are also some things in our current world that really affect people, and in a lot of cases they can be fatal as well. So that is something that we really want to do.
It would be really helpful to.
Yes, definitely, especially with like today's world where we're more accepting of mental health problems as compared to before. So this would be a really good thing if we could add on. But yeah, so basically to conclude, our project just basically shows how we can incorporate machine learning and AI to make healthcare more accessible to help users understand how their lifestyle is affecting their life and the possibility of them developing certain diseases. We're not trying to like obviously replace medical professionals, obviously that cannot be done, but we just want to like create a system that kind of helps or adds on to these medical professionals' jobs. And by like combining, again, machine learning models and AI, we've kind of like shown how like technology can kind of help in healthcare, which it has been doing, but it also can bring awareness to people that are using it, and it can also like help people take action in their lives, like genuinely be like, oh yes, I have to like eat these kind of foods. I need to like make my diet better. Like I can't just be eating like 2 kinds of foods that I really like. Like I really need a balanced diet, and why it's so important so I can like keep a healthy lifestyle and keep myself healthy in the future as well.
Yep.
So like again, like health isn't just about treatment, because once it happens, then obviously you got to get treated. But there are a lot of things that you can do before you're diagnosed with a certain disease or before you're diagnosed with something. Like so it's very much about like prevention and like being not having enough knowledge about these things and being able to help yourself. So that was one of the main aims of our project. So yeah, thank you so much, and I hope you liked it.
I definitely did. Nicely presented all of it structured. So yeah, definitely a good presentation.
Thank you.
What has your background with coding been like before?
My background in coding is actually very beginner because I did like a Python course a year ago. That was my start to knowing how to code, because in India, again, like I was just preparing for the engineering exam, JEE, when I was there in high school. So I didn't really have any hands-on coding experience. But after coming here and I was going to like college and everything, so I did that Python course that really introduced me to Python. And then I'm learning most of my classes in C++. So we're currently like, my current class in coding is object-oriented programming. So yeah.
Oh, all right. And do you have your interests in healthcare as well?
Not specifically, but one of the main things for this was that a very close family member of mine has a heart condition and is undergoing treatment for that. And one of the biggest reasons why they developed this heart condition was their lifestyle. So that was kind of the thought process behind this, which is why I wanted to kind of include that. But healthcare is not one of the specific things that I'm looking into, but it would definitely be something that I would like to get involved in.
Okay, understood.
Yes.
You have your demonstration ready with you?
Oh, yes, absolutely. I'm going to stop sharing this.
Yeah, sure.
Yes. Yeah. Is it visible? Like prediction of diseases?
Yep, it is.
Okay, awesome. Yes. So like here we have erythemia, which is a heart condition. For age, I'm just gonna do like 25. And then female, these are like 4 types of chest pains again. So I'm just gonna do typical angina. For blood pressure, I guess we do. Oh, actually, we can keep it 120. Yes. Okay. Right. Okay. And then here I can do like chest pain. I can do cough. I can and then I'll do 1 month here. Typical daily diet. I can do bagels, right? Lactose, milk. Lollipop, runny. 2 liters.
Isn't it 2 liters?
Is it? I thought 2 to 3 was good.
Might be. I thought it would be more than that. But anyways.
Oh, in terms of liters, I think it should. I don't know.
We'll let the AI decide. We'll let the AI decide.
Yeah. Oh, okay. So we get like, yes, the test is positive. Unfortunately. Yeah. So these are the main things. See, it is good. It's decent.
I was wrong.
I was kind of scared. I was like, wait, 2 liters not enough. But yeah, so here, like, again, I've done this before, so I knew they would say increase fruits and vegetables. But yeah, so it's going to say whole grains, protein, and then sugars. So yeah, this is mainly this is how it works.
Understood. Now, definitely useful to have a basic guide as to what to do. So, yeah.
Oh, yes.